Hey guys, this is lesson 2.3, the factor theorem. So to start, we are going to determine the remainder that results from dividing each one of these expressions. Now remember, we're only finding the remainder, so we can go ahead and use remainder theorem. So we sub in our test root, so we sub in positive 2 into our dividend. Gives us 2 squared minus 5 times 2 plus 6. And when we simplify, we end up with a 0. Now let's try that again. Sub in a test root of negative 4 into our dividend. And working that out gives us 0. Again, and one last time, sub in the test root. 1 cubed plus 5 times 1 squared minus 7 times 1 plus 1. And again, we get 0. So what does it mean? Why is getting 0 important? Well, when the remainder is 0, that tells us the divisor is a factor of the dividend. Okay, so let's take example A and let's go ahead and do the long division. So if we went ahead and did that, we know that x minus 2 is going to divide evenly into our dividend. So x into x squared. So x times x gives us x squared, x times negative 2. And we do the subtraction, so negative 5 take away negative 2. Bring down the 6. X into negative 3x, well, we need a negative 3. And we multiply. And we end up with 0. So if we were to write this out in a statement, our dividend equals the divisor times the quotient plus a remainder, which is just really a plus 0. Okay, so this leads us to our factor theorem, which says that if x minus a is a factor of f of x, so in other words, this divisor, if it is a factor of our dividend, we know that's only true if, when we sub in the test root, it ends up being 0. So this right here, IFF, that's not a typo. That stands for if and only if. So again, x minus a is a factor of f of x if and only if f of a equals 0. Okay, so this next question, we want to show that x minus 2 is a factor of x cubed minus 3x squared plus 5x minus 6. So in order to show this, all we need to do is show that we will get a remainder of 0 when we sub in the test root. So in other words, we want to show that f at 2 equals 0. So when we go ahead and do that, we get 2 cubed minus 3 times 2 squared plus 5 times 2 minus 6. Well, when we evaluate, we end up getting 8. Remember BEDMAS, so 2 squared first is 4 times negative 3. And we end up with 0. So we know that x minus 2 must be a factor. Okay, next example. We are told that x plus 3 is a factor of our dividend here, of this function. We want to find the value of k. So when something is a factor, we know that when we sub in the root -3, we should end up with 0. So let's go ahead and do that. We sub in -3, that's k times -3 squared minus 4 times -3 minus 3. We should end up with a value of 0. Okay, well, -3 squared is -27 plus 9k plus 12 minus 3. And now the only thing that you need to solve for is k. So on the left side, we'll keep the k, and everything else we will move to the other side, which gives us 18. Divide both sides by 9, and we end up with k equals 2. Alright, moving on. So what we're going to do now is something called the factor theorem. It helps us factor higher degree polynomials, so something of degree 3 or more. What we're going to do is we are going to find a test factor. So we're going to do a little bit of trial and error, sub in some values for a, and we're going to see that if we do sub it in, does it equal 0? If it does equal 0, we know that x minus a is a factor. And then we will do some synthetic division to determine the quotient and create a statement that shows the factored expression. So what we're going to do is we are going to sub in some values to start off. Now the values you should choose should be a factor of the very last term. So think of all of the ways that you can multiply to -8. So think of all the ways that you can multiply to -8. So for example, let's try the value or the number 2. 2 divides into a -8. So if we went ahead and subbed in +2, we get 2 cubed plus 5 times 2 squared plus 2 times 2 minus 8. Well, then we end up with 8 plus 20 plus 4 minus 8, which gives us a value of 24. So I know that x minus 2, right, because the root is +2, so the factor x minus 2 is actually not a factor of the above expression. So we're going to have to try something else. Let's try something else that divides into -8. Let's try +1 as a test root. So when I go ahead and sub in 1 for all of the x's, we get 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8. 1, 5, 2, 2 for 8. And this time, we get an answer of 0. So that tells me that x minus 1 is a factor. And now that we have a factor, what we can do now is do some synthetic division and break down that expression, that cubic expression, a little bit further. So if I do synthetic division, we're going to use our root of 1 on the outside, and we place our coefficients, 1, 5, 2, -8, on the inside, drop down the 1, and multiply. Add them up, 6 times 1, add them up, 8 times 1, add them up. So again, this confirms again that when we divide by x minus 1, we get a remainder of 0, and then our quotient of x squared plus 6x plus 8. So we'll write that out in a statement. So our dividend, which was x cubed plus 5x squared plus 2x minus 8, is equal to the divisor times our quotient plus any remainder, which we don't have any. So what we've done now is we've broken down a cubic expression into a quadratic and a linear expression. So something of degree 2 and something of degree 1. So that makes life a little bit easier because now we can take the quadratic and factor it further. So think of two numbers that multiply to -8 and add to 6. And we get x plus 2 and x plus 4. So this is as far as I want you to go. You must break it down so that it's fully factored. Okay, let's try again. So I want you to think of all the ways that you can multiply to 6. Come up with some test roots. I'll let you work on that. Try a few out, take a few minutes. But I will give you the spoiler alert right now. We are going to try -1 as a test root. So if I go ahead and sub in -1, I'm hoping that we will end up with 0. So when we work this out, we do end up with 0. So that 0 tells me that x plus 1 is a factor. So -1 is the root and x plus 1 is the factor. So now that we have something that divides evenly into it, we're going to do synthetic division. So the root goes on the outside, the -1, and our coefficients, 2, -11, -7, and 6, drop down the 2 and multiply. So -1 times 2, add them up. -13 times -1, add them up. 6 times -1, and add them up. So always confirm that you're going to get 0 here. And there's our quotient. So if we were to write this out in a statement, we would say that 2x cubed minus 11x squared minus 7x plus 6 is equal to our divisor, which was x plus 1, times our quotient, 2x squared minus 13x plus 6. Now, in this case, our quadratic here is a complex trinomial. So we're going to have to do some decomposition here. So this x plus 1 just kind of goes along for the ride. And we want to think of two numbers that multiply to 12 and add to -13. So those two numbers end up being -12 and -1. And now that we have 4 terms here, we want to do the factor by grouping. So there are 2 groups. In the first group, a 2x is common, leaving me with x minus 6. And in the second group, I'll take out a -1, leaving me with x minus 6. And because the brackets are identical, I can write my final statement, which says factor out the x minus 6, and then we're left with 2x minus 1. Alright, we'll do one final example. This time we are dividing a quartic. So we have a quartic. So in the last couple of examples, we noticed that cubics ended up with potentially 3 different roots. So a quartic could potentially end up with 4 different roots. Okay, so we are going to do some test factors. The first one I'm going to try is positive 2. We end up with 0, which tells me that x minus 2 is a factor. So we'll go ahead and do the synthetic division with our root and the coefficients 1, 7, 6, negative 28, and negative 40. So let's drop down that first term and multiply. Add them up. 9 times 2 gives me 18. Add them up. 24 times 2 gives me 48. Add them up. 20 times 2 gives me 40, and we finally end up with a remainder of 0. So we know we did a good job. Okay, so let's write this out as a statement. So our dividend equals our divisor, so x minus 2, and our quotient, x cubed plus 9x squared plus 24x plus 20, and then plus our 0 remainder. Now, this term here, our cubic expression, we need to break that down even further. So unfortunately, what we're going to have to do is factor theorem all over again. So what we'll do is we'll just give this a name for now. Let's just call this g of x. We're going to do some more test roots. Let's sub in, or let's try negative 2 this time, just into g of x, because we don't need to break this down again. We've already done that partially. So just into g of x, I'm going to sub in negative 2 and see if that works. So negative 2 cubed plus 9 times negative 2 plus 24 times negative 2 plus 20. And lo and behold, when you calculate this out, it does end up being 0. I am very lucky for guessing. So what we do now is we state that x plus 2 is a factor, and we do the synthetic division all over again. So the negative 2, the root, goes on the outside, and coefficients on the inside, 1, 9, 24, and 20. So drop down that first term and multiply. Add them up. 7 times negative 2. Add them up. 24 plus negative 14. Multiply. And add them up. And again, we know we did a good job because we got 0 remainder. If we were to write this out as a statement, I would start off with my original expression, x to the power 4 plus 7x cubed plus 6x squared minus 28x minus 40 is equal to the original divisor. So I'm just going to scroll up a little bit. So remember, it was equal to x minus 2 times g of x. So x minus 2 times g of x. Well, we broke down g of x into x plus 2 and its quotient. So x plus 2 times x squared plus 7x plus 10. And there's still 0 remainder. Now one last step is to take this quadratic and factor that even further. So x minus 2, x plus 2 we leave alone, and we want to think of two numbers that multiply to 10 and add to 7. So we end up with x plus 5 and another x plus 2. And because we have two factors that are identical, we simplify once more just by saying x minus 2, x plus 2 squared, and finally x plus 5. So that's it for factor theorem. If you have any questions, please make sure you ask in class. Have a great day, guys. Bye.